In this video, I'm still going over the concept of the compound events like joined with and, whether you have independent or dependent events, but also now adding to it our addition rule. So what if you had the probability of this event or this event occurring? So pause the video. This is just like a review one with our two-way table, and then I'll get into the concept here. And so here is what you should have gotten, or at least the setup. So the probability of choosing your female, 52 out of the 100, or someone who watches baseball, 36 out of the 100. But then remember, right, we always then subtract the overlap, the and. So basically, how many females watch baseball? 23 out of the 100. So then we would subtract that overlap because we counted those people twice. And that's how you should get the probability, which is 65 out of 100. So again, we're just adding that addition concept now to our probability events here. So again, whenever you have that addition rule where we're finding the probability of A or B, we add the two probabilities together, but then subtract the overlap, the and. So like here in this example, 3 cards with a yellow dot, 1 card with a purple dot, 2 cards with a blue dot. What is the probability of randomly choosing a yellow card first and a blue card second with probability? So this is 2 events that are independent, right, with replacement. So what is the probability of choosing that yellow card? Well, 3 out of 6, right? Or we could say 1/2. Then multiply that by with replacement, right? Because they're independent, put it back. What's the probability of getting the blue card? 2 out of 6, or 1/3. So that's how we get that this is a 1/6 chance of occurring. What is the probability of randomly choosing a yellow card or a blue card? So now here, well, what is the probability of choosing the yellow card? 1/2, right? 3 out of 6. Or what is the probability of getting the blue card? 2 out of 6, right? Or 1/3. Now, is there any overlap that we need to subtract? Like, is there any card that is both yellow and blue? No. So we don't need to subtract any overlap in this situation. Add them up, and that's how we get that this probability is 5 out of 6. So it's definitely a higher chance because we're just saying, what is the probability that you choose a card and it's yellow or blue? So now here we're going to determine the probability of choosing 2 yellow cards in a row without replacement. So now we're back to that compound event, but without replacement. So this is a dependent situation. So I won't simplify here so that we could visually see. The probability of choosing that first yellow card, right? It's 3 out of 6, 1/2. Then we multiply to that, but remember, without replacement. And remember, we're considering the probability that both cards are yellow. So we're going to say that that first card is yellow. But then remember, you took it out. So now what's the probability of getting the second yellow? Now there's only 2 yellow cards out of 5. Because remember, right, without replacement. So that's how we get 6 out of 30, which of course simplifies to 2, sorry, not 2, sorry about that, 1/5. So here, using a deck of cards, and I'll go to a visual just in case for those if you need the visual of a deck of cards. So here, what's the probability of getting an ace first and a 10 second without replacement? So again, we're back to dependent. So let's see, how are we going to set this up? What's the probability of getting an ace first? So how many aces are there? 4, right? So there's 4 of each kind. So 4 out of the 52. Then without replacement, we're going to get 10 seconds. So again, how many 10s are there? 4, right? Because there's no, we're not affecting the number of tens when you're talking about an ace previous. So 4, but out of 51. And again, that's what makes them dependent and multiply. Now, what is the probability of getting an ace or a diamond? So now here's our or, right? So we're going to get the probability of the ace. What's the probability of getting an ace again? So 4 out of the 52. We're going to add to that, right? Then what is the probability of getting a diamond? Well, how many diamonds are there? So remember, that's one of our suits. There are 13. So here we have 13 out of 52. Now we need to consider, is there an overlap? Is there a card that is an ace that is also a diamond? Yes. If you notice, we have one card here, right? The ace of diamonds. So that means we need to, sorry, wrong direction. We need to subtract that 1 out of the 52. So again, always consider with the or if there's an overlap. So that's why here you end up with 16 out of 52, which of course can be simplified, not 17 out of 52, right? Because we had to subtract the overlap. So now here, what is the probability of getting 2 diamonds with replacement? So now we're back to an independent situation. So again, how many diamonds are there for the first? 13 out of 52. Technically, it's with replacement. So again, same thing, 13 out of 52 and multiplying. So here, pause the video and try these questions on your own. And here we go. So we're choosing one card. What is the probability of getting the sports category or movies? So what's the probability of getting a sports category? Well, remember, right? Each of these are divided evenly, which means there are 40 cards, right, in each deck. Now, I could say 40 out of 200, but if they're split up evenly amongst the 5 categories, then that automatically would then simplify to 1 out of 5. Or getting a movie card, which is also 1 out of 5. Now, but keep in mind, was there any overlap? No, there are no sports cards that are also a movie card. They are separate categories. So that's why here no overlap is considered, and it's just 2 out of 5, or a 40% chance that this would happen. So then here, we're going to choose 2 cards with replacement. So you should have noticed that this is an independent event. The 2 events do not affect each other. What is the probability of choosing 2 cards in the sports category, which is just 1/5 times 1/5, right? Because there was no change to that, getting you a 1 out of 25 chance, or 4%. Suppose you choose 3 cards but without replacement. So now this is a dependent situation. What is the probability of choosing 3 cards in the sports category? So here I won't simplify so you can see. So the probability of getting the first sports card, right, is the 40 out of 200, which is 1/5. But then what is the probability of getting the second sports card? 39, right? Because remember, without replacement, out of 199. Then times, what is the probability of getting a third sports category card? 38 out of 198. That is how you set this up and multiply to get your probability here. So then here, pause the video and I'll go over these questions here as well. Try these questions, and again, if you need to, pause the video, go back to this visual here to help you solve the questions about the cards. And so here for the first one, you should have noticed that this was without replacement. So this is a dependent situation, drawing 3 kings, 1 at a time. So the first is, well, how many kings were there? 4 out of the 52. then times 3 out of 51 times 2 out of 50, which then simplifies, multiply to get your probability. But that is the setup for this first one. Now, what is the probability of getting a jack or a spade? So now here's our addition rule, right? So what's the probability of getting a jack? Well, again, that is 4 out of the 52. Then what is the probability of getting a spade? So a spade is one of your suits right here, which is the 13. So 13 out of 52. Now, was there overlap for this one? Yes, there is one jack of spades. So you do need to, sorry, again, wrong direction. You need to subtract that one overlap. And that's how you get the 16 out of 52, which simplifies. Now, what is the probability of drawing a red card and queen with replacement? So you should have noticed that this is independent, right? Now, how many red cards are there? Well, that's half the deck, 26 out of the 52, which is 1/2. Then what is the probability of getting the queen? There are 4 out of 52, right? Or this simplifies to 1 out of 13. And that's how you get 1 out of 26 here. So again, I got the 1 out of 13 from simplifying the queens because there are 4 out of 52, or there is 1 out of 13, right? If you think about it in each suit. So then the last here, we're going to use overall the deck. So if you hadn't answered these questions yet, go ahead and pause the video to answer these. And so for here, because you're using the 2 decks for the game, you're keeping in mind, so I'll just write the totals here, that there are 12 cards in deck A, there are 14 cards in deck B. So there is a total of 26 cards that you're using for this game between the 2 decks. So probability of choosing a C2 card from deck A and getting a C6 card from deck B, but putting the first pull aside. So you should have noticed that this is dependent. So C2 card from deck A, so that is 4 out of 26. Now, I'm going to again not simplify this so that you can see and make sure you set this up correctly. So this is 4 out of 26 or 2 out of 13, but times the C6 card from deck B. So C6 from deck B, there are 3, but now out of 25. And that is what you need to set up and multiply to get your probability here. What is the probability that the player will choose? A C3 card from deck A, or, so this was addition rule, a C5 card from deck B. So probability of getting the C3 from deck A, there are 3 out of 26. And then we're going to add to that C5 from deck B, so C5, so there's 4 out of the 26. Now, is there any overlap between these two? Like, is there a C3 and a C5 card? No, there's no overlap. So this is just 7 out of 26. Then what is the probability that the player will choose a C1 card, so or pink card? So that's from deck A. So here's another or. So probability of getting a C1 card or pink card. So C1 card is 5 out of the 26. Then we're going to add to that. How many pink cards were there? 14, right? Because there's the 14 between the 2 decks. But then you did have the overlap, right? Because there are 5 out of the 26 C1 are the pink. So that means here they just cancel out, notice, and that's how you get 14 out of 26, or of course that simplifies to 7 out of 13.